This is Algebraic Reasoning, Chapter 1.5, Exercise 9 through 16. This section has to do with modeling exponential functions. And there are really two sets of problems within this exercise set. There's 9 through 12 and 13 through 16. I plan to do here in the video lesson exercise 9 through 12, which are from this certain scenario. And here it is. For questions 9 through 12, use the following situation. Most cars decrease in value over time. The table below shows the value of Carla's car from the time of purchase. And here you have the year and what the year number and which calendar year that year number corresponds with, and then the value of the car. And part of this happens to, there's an understanding that exponential decay would be a good model for a car value. And we call that certain thing, that rate of decay, we call it the depreciation rate. And usually you'll see that in percentage. And so we're going to figure out what that is from the data. Okay, so you have all these ratios here, and of course for an exponential model, of course in question 9 it says use the data set to generate an exponential model. So you already know what you're going to be looking for, and that's going to be for R, your common ratio. And what do we do to get common ratio? We take one term divided by its predecessing term. So we're going to take 24,180 and divide it by its predecessing term value, which is 29,870. And find what that equals. Then we're going to take 20,480 and divide it by its predecessing term, which is 24,180. Okay, then we take 17,420 and we divide that by 20,480. And then we have 14,585. And we're dividing that by 17,420. And then finally, we have 12,124. Divided by 14,585. And we're going to get a good look at our common ratio from these 5 calculations. Okay, so the first one, we say 24,180, and we divide it by the original purchase price of the car, 29,870. So we get this fraction here, and we're going to decimalize that by pressing Control Enter. So we get 0.809. So that's going to be like a 0.81. And we'll talk about what that means after a bit here. We're going to do the next one. And for this one, we have 20,480. And we're dividing that by 24,180. And we get that fraction there. Okay, this one here, we get 0.846. Okay, next. So we get a little variation here. Next we put 17,420. And we're dividing that by 20,480. And then we press Control Enter. We get a 0.85. So maybe it's going to be a 15% depreciation rate after all. So we'll do a couple more. We got 14,585. And we're going to divide that by 17,420. Okay, Control Enter, get our decimalized version. So about 84%. And the last one we're going to look at is the final value here, year 5, 12,124. Divided by 14,585. And we get that fraction, we get 0.83. So I'm just going to round up here. I'm going to call them, the first one we have is like 0.8, I'm going to call it 0.81, 0.85, 0.85, 0.84, and 0.83. So we come back here and we say this was 0.81, 0.85, make sure I get these right. Yeah, 2 8.5s and 8.3. 0.85, 0.84, 0.83. So if we just look, we could add these up and divide by 5 to get this thing pretty accurate. I don't know. This is like, if you take an average in this bunch, looks like it's about 0.84. Well, let's just do it because we can. So we're going to say 0.81 plus 0.85 plus 0.85 plus 0.84 plus 0.83. So we get that value, and we're going to divide by the number we have, 5, to get an average. So 0.836. Now we just use 0.836. That'll be fine. So that'll be the value we put in our model. So that's going to be our R is going to be 0.836. Now what kind of depreciation rate is that? Well, to get your depreciation rate, this is an additional here, depreciation rate, you take 100% and you subtract out the percentage here of the value. So you're going to subtract out 83.6. So we're going to get 16.4% depreciation rate. Okay, that's a depreciation rate because that's the value the car decreases every year. And really, between year 0 and year 1, we had a really steep drop off from 100% to 81%. And that really is indicative of a new car being driven off a lot. But we'll just stick with this. So what is our exponential model? Our exponential model here is going to be car value, and I'll say V, is equal to our initial value, which is 29,870. Let me get this here. Pen's a little glitchy here. Okay, here we go. There we go. 29,870 times our common ratio, which is going to be 0.836 to the power of year, or f of x, and they said f of x, right? Value of car f of x. So v, I call this v for value. In the context of the problem, they say f of x. So I'm just going to change that to be consistent with the problem. I'll put f of x out front. So that's going to be our function. It says, so this is going to be our answer to 9. Okay, problem 10. What do the y-intercept and base from your function rule mean in the context situation? Well, this will be a y-intercept. I'll put y-intercept equals car value when new. And what does the base represent? Well, that's going to be the common ratio. That's going to be the what you multiply by the car value to get next year's car price, or next year's car value. So we will say this. Okay. So that'll be answer to number 10. So I'm just going to label these. That's 9 there. This is 10. Problem 11. In what year will the car be worth about $5,900? Okay, I'm going to go to the calculator here for this. And what I'm going to do is this. I'm going to put the function in the calculator. And to do that, I'm going to go with Control I, TI Inspire CX calculator, add graph. So we're going to put 29,870 times 0.836 to the power of x. And so when we enter that, and we do not see anything, that's going to be way up here. We could get the, what I recommend doing here is we'll just go to the table view just to keep things easier. So if we go to Control T, we can see when the values change. So we're interested, and we can see that the values are going to pretty well match. Year 5 here says 12,197, and I think it's 12,124 in the actual. So we can go down to see $5,900. Let's just keep on going down to about $5,900. That's going to be right here, about 9. So the way this is set up is it's going to be 9 years after 2007. So we say problem 11. So 2007 plus 9 is going to be about the year 2016. And it's going to be, our answer to number 11. It says, okay. 12, use your model to predict the value of Carla's car in the year 2020. Well, what you're going to have, you start out 2007, 2020. I'm just going to write out here. Okay, 2020 minus 2007 equals 13 years, right? So we're just going to go to year 13 here. And to do that, just keep on going down. Year 10, 11, 12, 13. So I see approximately $2,910, $2,910. Okay, so that'll be the value of the car. And so that's all those things answered. And that's as far as I'm really going to take the video lesson. I will point you ahead to have you work on 13 through 16. It's a similar scenario where you're using data to find an exponential function, model the situation, you answer questions 13, 14, and then 15 and 16. So Elisa and the ribbons. Anyway, good luck in all your exercises, and thanks for viewing.